All right, good afternoon, everybody. God, I feel so powerful. Is everybody having a good time? All right. So I was asked ask for a shameless plug before I walked out on stage, before I introduce our next guest, which I'll definitely get to. I know this guy long time very well. But if anybody wants to take pictures, feel free to take pictures of anything you want. But if y'all could, whatever social media you use, LinkedIn, anything like that, Instagram, it's probably not a huge thing, but if you do it, by all means, please post it with the hashtag AltiumLive 2019. If you could do that, we'd greatly appreciate it. It just helps us get the word out, obviously. Now, enough with the shameless plugs. So, my next guest is, I think the word dynamic is fair. I like the word turbo nerd. He oozes all things engineering, has his own has his whole life. And I met him, I think it's probably been 10 or 12 years ago now. And I met him because he was doing a television show. And it was really a television show for guys and gals like us. Like, it was really targeted at our demographic around just creating really, really cool stuff and what you could do with an idea and, some tools. Clearly, the television industry wasn't kind to Joe or he wouldn't be here. Has anybody seen the show Prototype This? Yeah. Joe's seen it. This guy's just a really dynamic guy. I can tell you that when we were miking up last night, testing things, he said, well, we're going to have a wireless mic because I might do some dancing. And if you know Joe, I suspect he probably will do some dancing. It's another sort of curious sort of tidbit about him. I hadn't talked to him in many, many years, and he reached out to us just recently in a perfect timing for us to say, well, you should probably consider speaking in AltiumLive. And in true hacker fashion, he was reaching out because he wanted some more free stuff, which we were happy to provide. But when we did the video conference, because we wanted to pitch this event to him, I remember the video coming on, the video camera coming on, and it looked like he had a backdrop behind him, because it was clearly a lab, and it clearly had all the little bins with all of his little passive components in it, which probably many of you have. But, I mean, this guy is really a lifestyle engineer. And as a hacker, he's even got one of those fake names that hackers have. I think he's spoken to Congress, or maybe the Senate. But let's go ahead and we'll play his video and then bring him out. Thanks very much.
Joe Grande, also known as Kingpin in the hacker community, is a computer engineer, inventor, teacher, device security expert, runner, daddy, honorary doctor, TV host, member of legendary hacker group Loft Heavy Industries, and the proprietor of Grand Idea Studio. Joe holds a Bachelor of Science degree in Computer Engineering from Boston University and an Honorary Doctorate of Science in Technology from the University of Advanced Technology in Tempe, Arizona. Joe has been creating, exploring, and manipulating electronic devices since the 1980s and has been using Altium Designer or its predecessors for nearly just as long. As the first hardware designer to spark the Badge Life electronic trade show badge movement, he certainly has a flair for the art of PCB design. Ladies and gentlemen, please welcome Joe Grande.
Hello. Can you guys hear me? You can hear me? Okay. I've never been called a turbo nerd before. I think that's the first time. That's awesome. Who has been called a turbo nerd before? Oh, yeah, of course. Is that Ben? Oh, yeah, okay. Ben Jordan from Altium. Okay, that makes sense. Cool. Thank you for having me. My name is Joe Grande. That intro is great. It's almost like I wrote it myself. This presentation is a little bit different because, we've been going through technical talks today, yesterday. We're going to have some tomorrow. So this is a little more fun, kind of showing the lighter side of engineering. And I'll sort of explain a little kind of bio as we go and then get into some projects, get into some design tips. But really, it's just looking at kind of these crazy worlds of the hacker world. And in the hacker world, in this case, is not the cybersecurity sort of break things, break into systems and steal money and stuff, though that is a valid and sometimes fun thing to do, if you don't mind going to jail. And then the engineering side, right? So I am a professional engineer. I know we have lots of professional engineers here. And a lot of times engineering is, we get so focused on our project, we have all of these constraints and problems to solve and boards to route and everything. And sometimes we kind of lose our passion, right? Or we forget that this is, like engineering, probably like you guys are a lot like me, right? Like engineering is something that you've done for a long time, and it is a passion. So these are just fun, crazy projects and kind of combining the hacker world and the engineering world. I assume everybody has some sort of awkward, computer nerd picture, right? No one's going to admit it. I know there's a few, right? They're awesome. These are the sort of things of like, I've loved computers since I was 7 years old. And my first computer was an Atari 400, and discovered bulletin board systems, started trading information with other people, and really discovered this kind of underground world of kind of just other enthusiasts, other hackers, other people that loved computers. And it was just such a fascinating time. And it's just something that has stuck with me. So when I was a kid, people would say, oh, what are you going to be when you grow up? And most people are like, I'm going to be an astronaut or a scientist, or probably not a scientist, a firefighter. And I was like, I'm going to be an engineer. And people are like, what? Like, you're weird. In 5th grade, I went to a Halloween party wearing all blue, like a baby blue sweatsuit, because I would always wear sweatpants and sweatshirt, carrying a 5 1/4-inch floppy disk. And people would say, what are you? And I'm like, I'm a hacker. So, it's just, and of course I went to school dressed like that the next day, right? So they didn't really, I don't know. It's just, this is all I've done, is kind of exploring computer systems, building projects, and it turned into a career. And it's amazing, because the engineering world is fascinating. I've always been involved and curious about hardware. But for a while, you see I have my Atari, I was connecting to bulletin board systems. I did try to write software first. And this was my first program I ever wrote, called Electric Dog. You'll see if you can guess who it represents here. But this is the first program I ever wrote. I still have the floppy disk for it, which is pretty amazing. I converted it to an emulator. And so here we go. So I did this, and then I decided to start designing hardware. Can anybody guess what this is? I guess it was in the source code, so if you looked really fast, you could see it. But K9, it's K9 from Doctor Who, right? Because Doctor Who is amazing. Yeah. One guy's like, Doctor Who. I agree. But only the doctor with the puffy hair from the 70s, right? Tom Baker, I think it was? Yes, that was the one. Anyway, so I did write some software, but really hardware was my passion. Even back then, I would build projects out of magazines, Popular Electronics, Radio Electronics, Nuts and Bolts. I remember my friend's dad had Byte magazine for some reason. he wasn't into technology, but somehow he had a whole stack of Byte magazines up in the attic, starting with Byte 1, and I would flip through those, and it was amazing. This was in the early 80s, and I was reading this stuff. And it was just a great world. What really kind of set me over the edge, and this is where I realized that I could do what I love to do and be a hardware engineer, is I started building these mischievous hardware gadgets. And that's what really clicked. When I realized that I could take what was in my head and turn it into an actual physical product, like, that was amazing, right? And I'm sure everybody here can appreciate that. Like, when you design a product, and a lot of times engineers don't get a lot of credit, right? Because we're sitting there, like, working on something in the lab, and then the product comes out, and somebody else takes the credit for it if they, are on stage and have a better personality, or a black turtleneck or whatever it is. But the engineers are the ones that should get the credit, right? And there's something really satisfying about seeing your products in the market. Except on the other hand, I just was at a surplus store the other day and saw one of my products. And it was a big box of like all of these. They were portable monitors. And it was actually the first USB powered and USB connected second monitor. So you could carry a second monitor with you and plug it in your hotel room and make it easy to travel with. And I saw a box of those in the surplus store. And the owner of the shop saw me flipping through them, and I was taking some pictures and stuff, and he's like, I'll give you a great deal on all those. I'm like, no, I designed it. I don't want any more of them. But it was also sort of a bummer, because it was like, oh man, like I spent so much time on this, and now it's in a surplus store. So that's sort of like, the engineering, the arc, right? And then it's like, oh. Anyway, so the mischievous gadgets, this is where I realized, hacker and engineering coming together. The upper left is this ring busy device, I called it. And it was just a resistor, a certain resistor value that would connect between the ring and the tip of a phone, RJ11, old landline phone. And what would happen is you could still use the phone from inside the house, but if somebody was calling you from outside, it would ring once to them and then give a busy signal, which is weird. But inside the house, it didn't ring. So it was perfect for, telemarketers and stuff like that, but I wasn't doing it for that. I was doing it so my teachers couldn't call the house to tell my parents that I got in trouble. And then later on, it actually ended up being useful when I was doing a lot more of phone phreaking, so sort of exploring the telephone networks in ways you shouldn't, using phone codes and teleconferences and all sorts of stuff that costs lots of money, and we're billing it to some other corporation, so that would prevent the phone company from calling me, and it was great. Upper right, I like that one. That was like who here had a pager? Yeah, man, you guys are so young. Yeah, this was a pager, except inside the pager, I put what was called a red box, which is a multi-frequency tone generator. I think that one was a 556 timer to generate 2 frequencies, and that would emulate the sound of coins going into a payphone, because that was all in-band signaling. So you could hold this pager up to the phone, and when the phone said, insert 25 cents or whatever it was, a dime, you would just go beep, and it would play the sound, and then you would get your free phone call on the payphone. And this was something very lucrative, and I sold a lot of those when I was younger. The statute of limitations is far gone, so I'm okay to say that. But it was something that a lot of people were doing because the telephone system was this big, massive, faceless corporation, and we were curious kids that wanted to communicate with other people and talk to people. And that should be applauded. Like, we want to talk to our friends. So that was a fun one. And what else? Down there, lower left, that was like a little, I think that also was a 555. That was a high-frequency generator. So what I had is that was inside like an Altoids box. So I'd bring that into school, put it on my desk, turn it on, and the frequency was so high that it was kind of bouncing all over the room, so you couldn't tell where it was coming from. And all the kids were like, oh, it's so loud. What's that beeping sound? And the teacher sometimes could hear it, because sometimes, older people lose their high-end hearing. But when they could, it was awesome, because everyone's searching around trying to find out where the high-pitched frequency was coming from. And of course, I'm sitting there like trying not to smile, which is almost impossible. And I didn't get in trouble for that one. Universal garage door opener, the one right next to that. So just replacing, that one I had I think it was a decade counter. And again, another 555, right? The ubiquitous chip that can do everything that you want, mischievous and not mischievous. So that one basically replaced the 10 dip switches that were setting the password for the transmitter that would match the receiver. And you push the button, and it's just going to cycle through all the possible combinations until it opens the garage door, of any garage door with that password. And that was cool. I never actually used that one, for real, I swear. But my parents had that one. So that was, for me, actually the first time that I got to prove and sort of show a security kind of hacker-related problem, right? Because I went to my parents and said, hey, look, I built this thing. I can now open our garage door and steal everything in the garage. And they said, oh, because that part wasn't alarmed. And they said, oh, great. Now they're just going to move everything out of the garage into the alarmed part of the house. So that was like my first experience of educating somebody with some knowledge that they could use, right? It's like using these mischievous things, but then teaching. So yeah, lots of crazy things. And at that time, most people that were into hacking, it was software, it wasn't even network, right? It was software, cracking games, bulletin board systems. But I read this file, The Conscience of a Hacker, was something that was written in 1986. It came out in Feranec magazine, which was an online electronic zine of articles. It was one of the first ones, if not the first one, that kids were writing articles about subversive, mischievous sort of stuff. And this was part of a larger sort of manifesto by a guy named The Mentor, who is still around. And I read this, and I was like, yeah, this is exactly me. Like, I'm not the only one. Like, I had friends doing stuff on bulletin board systems, but I didn't have anybody around me that also was this passionate about kind of thinking differently, and kind of exploring stuff. So this really, I'm not going to read the whole thing. You probably already read it by now. But it's something that was really powerful, and it really hit me of like, okay, I can be a hacker, I can be an engineer, and to me, this all seemed normal, like the free phone calls, the pushing people's buttons. I was always a mischievous kid anyway in the real world, so doing it online was just an extension of that, which was really kind of fun. I did end up getting in trouble, surprise, surprise, for hacker-related things, and that really changed the direction, because then I was like, all right, I don't want to go to jail. I was 16 at the time, so luckily, the other people I got in trouble with were much older, and they had sort of different outcomes than I did. But my parents were nice enough to sort of say, okay, we know that this is your lifestyle, right? Like you are into technology, you're into computers. If they prevented me from using a computer, I would just go find a way to use a computer. So they sort of supported me and just redirected the right way. So I ended up joining up with a hacker group called The Loft, which was one of the first publicly facing hacker groups based out of Boston, where I'm from. And these guys were all at least 6 years older than me, sort of mentors to me. And probably the most important thing that came out of this whole experience at The Loft is we were really focused on sharing the good side of what hackers could do. You know, like educating people about security problems, empowering people to fix their own problems instead of relying on the big corporations to do it. Because a company like Microsoft back in the day when we found problems would take a long time, or they wouldn't even believe us. So that's really where I learned the importance of sharing information and empowering other people and letting people build on your own work. A lot of the projects I'll talk about are open source, meaning the hardware designs are available, schematics are there, BOM, you know, all of that, firmware. So you can take those and build on them, and that's how we get better knowledge for the whole community and maybe the whole world, right? Because you know, everybody has a different perspective, and you might see something and say, hey, I'm going to build on that, and I'm going to make some product that's going to change the world or help somebody. And like that's really the cool thing about sharing information. We did end up testifying in front of the Senate. Lawrence mentioned this one. This was a terrifying experience because you have 7 hackers. We were all using our fake names. We were actually the first group to testify in front of the Senate. This was in May 1998, using fake names that were not in the witness protection program. So it was like pretty crazy. The first people to use fake names. And to have a bunch of hackers go up in front of the government, you know, we're pretty much, at that time, and some of us still are, very kind of anti-authority and kind of always pushing and things. So to have 7 of us look like this and show up talking to basically our grandparents was crazy. It was a huge deal, and I didn't realize how big a deal it was at the time. This was my first public speaking experience ever. And if you read, but we're actually in like a transcript, the official whatever U.S. Congress book, and it says Kingpin, blah, 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 because I didn't really make any sense. But it was really cool, and what we got called up for is to educate the government about the state of computer security and like how are things going, because we know governments are slow and we know sometimes companies are slow. So we laid out this like, you know, scenario of what hackers could do, and we're 7 guys in a warehouse. We're not some, you know, state-sponsored actor. And this was 21 years ago. And it's funny because maybe it's not funny. A lot of the stuff we talked about there is still completely relevant now. And we did a 20th anniversary last year to talk about it, and I looked through the transcript, and it was like, oh man, because now we're designing so many more products, a lot of network-connected devices, where back then people were just getting into computers. Now we have millions, maybe billions of internet-connected devices. So we have all of these now resource-constrained computers on networks that just make security way, way worse. You know, for every good, secure system that's there, now we have all these other ones. So it's a little bit terrifying. But it was really fun, and it turned out to be a pretty big deal that we were actually mentioned in lots of press and other things, and we were even made fun of, which I guess is sort of cool. This is what really set it home for me of like, oh, this is actually kind of cool. So this was on Conan O'Brien the day after our Senate testimony, and I just love this clip because it shows we were trying to reach the mainstream audience and talk about how we can think differently and still raise awareness of stuff. So here, I'll play this one.
Kind of weird. I found this. Talk about something that's a little frightening. I read this in the news yesterday. A group of computer hackers told Congress that hackers are now capable of shutting down the internet, redirecting commercial flights, and transferring millions of Wall Street dollars around the world. It's weird, yeah, which means the only thing hackers still aren't capable of doing is losing their virginity.
He's probably right.
There's a guy with thick black glasses crying right now in the 3rd row.
And moving all the money out of your account.
Yeah, right. I'm completely screwed. Yeah. Now show that red-haired freak. I don't fear nerds. That's the bravest stand I ever took here on the show. Wow. I'm sorry, I might be going out on a limb here, but I don't fear the nerds.
Yeah, so getting made fun of is cool. I don't mind, especially on Conan O'Brien. So yeah, that was a pretty big deal. One of the things we actually did at the Loft is we're totally self-sufficient. So we were basically a clubhouse, and we would sell T-shirts and other little project CDs. Remember those? Like CDs filled with different text files and things. And my first professional circuit board that I actually did with Easy Tracks, with ProTel Easy Tracks, was this POC-SAG decoder. And this would take in a unfiltered version of the analog signal from a radio. You had to modify the radio to get a good signal out. And it just went through this massive op amp, and it would just jack everything high or low and kind of make a digital signal out of it that you then feed into, I think it was, I know that's a DB9 on there, but I'm pretty sure it was to a parallel port. And then you could just read those pins, and it would decode, and there was some software that would run on the PC that would decode the POC-SAG traffic, which is the pager traffic from the pagers that none of you had. And we could, we saw drug deals, we saw fights, we saw taxi information, all sorts of stuff, which totally wasn't legal at the time. And I don't even know if it's legal now, but this stuff is all going through the air. So this was sort of a way that we could empower other people and say, look, you can see what's being transmitted around in your area by just building this circuit. So we sold these little kits. But probably if Eric Bogatin was looking at my design, he'd be like, there's no return path there, there's no ground pour. Your signal integrity is horrible. And he's totally right. The placement was the worst. Because I'd never designed a professional board. And we panelized it, V-scored it, but I had a DB25 that shipped with it, and what I should have done is put the connection on the end so you could just solder the cups of the DB25 on either side of the board, but instead you had to run wires. And it was a pretty bad design, but it still let people use it, but it taught me a lot about, all right, now next time I'm going to do things a little bit better. But that was sort of the beginning. That was 1996, and that was the beginning of using ProTel. So I think like 2 people raised their hand. Who saw Prototype This? Ben and a few other, nice, okay, a few people. So this was a show, very short-lived show, cult following. And this was a show that we filmed for Discovery Channel, and just like The Loft, where we were kind of focused on sharing the hacker message with the world. Prototype This was all about sharing the engineering process with the world. Because, again, like most people don't realize what engineers do. And even nowadays, my own kids, like I'll work for a few months on a project, and they're seeing every day some prototypes and this and that. But they still don't, it doesn't click until the end, and they go, oh, now I see you've designed something. So this we really wanted to show the process. And it was hard because a lot of times, most work is going on in here, in your head, maybe on paper. And how do you show, how do you make soldering look sexy, right? Like, there are ways, trust me. Maybe not that they showed on the show, but it's not welding, it's not grinding, we're not building a motorcycle, we're building pieces of hardware. So it was a real challenge to kind of show that process in a fun way. But again, we went through the real process, and the thing here is we were just building ridiculous, crazy prototypes. And some of the stuff we built, actually, this was 2007 when the show aired. There are products now, I'm not gonna say based on what we designed, but they're based on what we designed, that other people have taken and then turned into real products, because we were just building stuff and then moving on to the next thing. So yeah, crazy autonomous things. And this was like right before, like pre-Arduino explosion. So we were using a lot of basic stamp, a lot of more bare metal types of boards. And yeah, this was something where we were building our lab, and it was like, you can have a dream lab of whatever you want for TV. And I was like, oh my God, this is amazing. Because I'm an engineer, like I didn't expect to be on TV, like that's crazy. And who knew? So I said, I want a circuit board prototyping machine. I need Altium Designer. And then we started calling everybody up, and that's where I met Lawrence. And yeah, I am not afraid to ask to get free stuff. The worst someone's gonna say is no, right? So always ask for free stuff. That's how I got my circuit board prototyping machine too. And so we said, hey, can you sponsor the show, and we can show Altium Designer on the program? And they said, sure. So that was the beginning of a great relationship. And we did 13 episodes, so they are available like on DVD. some streaming services, you can steal them on the internet, I don't care. Just watch them and spread them to everybody, because they are still relevant, even though it's 10 years old. And it's pretty cool. So this picture on the right was a high-tech firefighter suit. That was a basic stamp with a thermal infrared camera and a bunch of other sensors all wired up and a heads-up display. We decided to have like a superhero kind of nozzle to shoot fire extinguisher out of. But that episode, we actually met with real firefighters from Modesto, California, which was super intimidating, because here were like a bunch of pretty much all skinny nerds, and then there's these like massive firefighters and mustaches, and they're carrying lots of gear and putting out fires, and we're like, hey, we use computers. And but we got to meet with them and talk about their problems and say, what challenges do you have? And they're like, well, we can't haul gear up the stairs because, well, we have to, but it tires us out when we get to the top. When we're searching in a smoke-filled room, it's hard to find our partners, it's hard to find any victims, because we can't see anything, we don't know the status of all of our gear. So we came up with these projects, and then we got to build them and then let the firefighters test them. And it was awesome. And so that was really satisfying. This one on the left, we were just testing the strength of an airbag. So we had to use a dummy because they wouldn't let us actually use a person. But don't do that, because it turns out that the airbags are really strong if you lie on top of them. This show, by the way, this was filmed by the same production company as Mythbusters. Everyone knows Mythbusters, right? But nobody knows Prototype This, because we spent too much money making the show. I think it was like, I don't know how many hundreds of thousands of dollars per episode. But this is the type of stuff we're building. This is 10-foot giant boxing robot, so hydraulic controlled, that would move based on players outside the ring. So I'm on the right, and then we have a Golden Gloves like national champion on the left, who she was unreal. And actually, she gave me, we were sort of, I thought we were kind of fake boxing for the show when we were like meeting, and she was doing all the boxing moves, and she gave me a bloody nose, and they stopped the tape, and they're like, no, we need his face for TV. And, but it was pretty cool. So these are hydraulic controlled. We had glyphs on the back. So this was the first time I had heard of like augmented reality. And Zaz, one of the other guys on the show, is a software robotics engineer, and we used what was it? OpenCV and AR Toolkit was an open source toolkit for doing augmented reality. So based on, we had cameras and they're watching the glyph move, and that's gonna move the robots in different ways. Totally ridiculous. We had a 30-foot tall water slide simulator, because water slide rides are always too short. So this one this one's also, actually no, the boxing robots were pneumatic. This is hydraulic. So we had crazy hydraulic systems, and this thing would spin, and it would sound like a freight train, just like rolling. And it was welded together by some of the best kind of artists and welders in the Bay Area over the course of, I think it was like 6 weeks. And the TV show liked to say everything was done in 2 weeks, because that's marketing, but that's not always true, because engineering sometimes doesn't work. And actually, that's a good point I forgot to mention. When we started doing the show, the production company and the network was like, everything has to work the first time. And we're like, wait a second, like, do you know what engineering is? And so they're like, no, it has to work. We're like, how do we know if a 30-foot water slide simulator is gonna work? Like, we have no idea. But the first few episodes did work. One of them did fail, and I'm not gonna tell you which one, so you have to watch all of them to find out. But once we failed, the Discovery Channel was like, this is amazing. You should fail more often, like, wow. Because that's where you learn, right? Like, the failures are actually the best way to learn. As much as it sucks, and that's like when you hate engineering the most, when things don't work, once you solve that problem, you're like, yes, I love engineering. And that's what gives you the confidence to keep doing stuff. So they saw that, and they saw as we were solving problems, like it was actually, they liked that. So, that was kind of cool. Down here, this was, a lot of this stuff was designed with Altium Designer. The thing on the bottom right, these are battery management boards for these individual lithium iron phosphate batteries. And these were massive batteries that we used in this all-terrain vehicle up in the right that mimicked a six-legged creature walking. And these cells were so new that there was no charging circuitry available or anything. So we had these little management circuits that we had to build and get fabbed and assembled within 24 hours because the TV crew was scheduled to film like the test. And we're like, wait, that's really hard to do. But we ended up pulling it off and built these little boards that would charge the batteries, and then they would monitor the charging and discharging so you don't go under voltage and stuff. So sometimes we would build things by hand with a breadboard. Sometimes we would have to do boards like that. Here's a truck that would elevate itself and drive over traffic, and it had these which is great. This is in San Francisco at the Embarcadero, and we actually slid on top of another car, which that was a rental car. We rented that one and got the full insurance coverage on it. in case it crashed down on it. And we actually, when we returned it, there was like some grease marks along the side because one of the shots we were driving over it this way, and the wheels, which were greasy, touched the side. It was pretty awesome. But yeah, this was controlled with, the original circuitry was the upper right. And there's like this acrylic plate that we had used for some other build that I grabbed, and I had a bunch of little circuits kind of all hacked together to prove the concept. And it actually worked just like that, but I was a little nervous about having that in the car because it's bouncing around. So I ended up making a board and everything on there, and it used a little wireless PlayStation 2 controller so you could drive the car outside, even though the car did have autonomous control as well. But just really crazy. This was also a basic stamp with a bunch of transistor drivers to drive I think those were to drive the motors or whatever the actuators were to move the thing up and down. One crazy thing, these used what are called AirTrax wheels, these Mecanum wheels. So they're omnidirectional, you can drive them in any direction. And we talked to that company, they had only built these things for the Navy, for like aircraft, what are they called? The things like a forklift to use on an aircraft carrier. So very small turning radius and everything. And we're like, we want to attach our own circuitry to these things. And they're like, okay, well, we don't know what's going to happen. So we ended up having some of the guys from AirTrax come by, and they gave me a little document that said, like, here's the input for the different controllers. Just send in analog voltage 0 to 5 on, X axis and Y axis, and that's going to drive. The controller itself will adjust the wheels the way it needs to go. So I just had to provide 2 analog voltages. We didn't find out until we were doing our testing that if you don't provide any voltage on those lines, like if those signals get lost, so I guess it wasn't 0, it was a little bit above 0. If it was nothing, then those things would just behave in some erratic way. It was not failing in a safe manner, right? So always check your conditions, and you want to fail safe, fail closed, whatever it is. Don't go bonkers. So we had to put a kill switch on there, so we had somebody following along with a big red button that would disconnect power. And that's terrifying when you see a giant truck on wheels, realizing, like, if my circuitry doesn't work, that's going to be a problem. So here's a prototype of testing those wheels. We called this the self-driving couch. And this was something that wasn't, I don't even know if they had this in the show, but I had my producer filming us just as we're kind of messing around, getting ready for a shot. And I thought this was sort of fun.
Okay, last part.
Yeah, go ahead, pull up.
This would have been awesome driving down the street or something. And I'm using the controller underneath the blanket.
Joe, what are you doing?
So he said a bunch of choice words after that, like stop messing around so we can film the show. But yeah, it's all the behind the scenes stuff that was really fun. Some other stuff that I've done that's kind of sort of engineering related, and these were all different DEF CON badges. I know this was mentioned in the intro. These were the first electronic badges done for conferences that weren't just a lanyard with a piece of paper on it. So trying to do artistic electronic badges, trying something new and trying to educate and entice people with hardware. And the first one in the upper left corner is from DEF CON 14. DEF CON is the world's largest hacker conference. This was something where we just were curious, like, how are people going to react to a piece of hardware that they could hack on? Because it's open source. We had this was PIC-based, so we had an in-circuit serial programmer interface on the backside so they could change the firmware, modify it. We had a little badge hacking contest. And there was only, like, I think maybe 6,000 people at that show, only. But for a board like this, it's pretty simple. It just had the complex cutout, but the circuitry itself was like a PIC with those jumbo LEDs. And we just didn't know what to expect. But it turns out people liked it, and they hacked it and did crazy stuff. So we continued doing that over the years, kind of iterating and trying new technologies, trying new design techniques, all using Altium Designer. And over time, little by little, it's like, oh, I've never done a crazy stencil cutout, or I've never done capacitive touch. So it was a great opportunity to kind of try new things and then let the hacker community kind of hack on it and mess around. The one in the lower left I thought was kind of cool, because those are 7 different puzzle pieces that fit together. And you see there's a lot of colors on there. So that light gray is the solder mask, and then the darker gray and the black and then all those colors are just different silk screens. So we would just silk screen the board multiple times in the process, right? Silk screen the panel. So you could do interesting stuff like that, and it didn't really cost that much more. We had an aluminum substrate board, and then we'd laser engraved on the top side because we didn't need it for heatsink or anything. We just wanted it to look nice. The one in the upper right was one I did this year. Actually, the two on the right I did this year. Those were probably the hardest engineering projects I've ever done, and which was surprising because it's like, oh, it's just a badge for a conference. But it's like when you try something new, you never know. It's either going to work or not work, and it's really stressful when you're dealing with something that has a hard deadline, right? And you know it has to work by this date. The one in the upper right was my first attempt of doing flex circuitry. So that's a flexible board with a white coverlay on it, and a bunch of LEDs on the top, a bunch of LEDs on the bottom. That one was actually the first time I designed an Arduino circuit. Because this particular conference, this was DEF CON China, so this was the first time that the conference was held in China. Normally it's in the US. And that audience had, it was sort of a new audience, a new hacker audience. So I said, I'm going to use an Arduino on the back side. I had a little stiffener on the left side with an FPC connector. And the concept is as you completed different tasks at the event, you'd plug in your flex board to a little programmer, and it would enable different LEDs on the bottom. Once you enabled the roots, then all the branches would light up and show off and blink the lights to show that you completed everything. And I'll show you some challenges with that one later on, but that was sort of a fun one. And then the bottom right was ridiculously crazy, and that's a hand-cut Brazilian quartz crystal on the front. We made 28,600 of those. I'll talk about a design challenge with that also. And that was my first experience using VIA in pad and buried vias and micro BGA and all sorts of stuff, which you probably shouldn't do when you're making 28,000 of something, in a short time frame of like, I'm going to try using every single tiny part I can. But I did, and it worked out. I just got a lot of gray hair in the process. So here are just some ridiculous projects. This is one kind of a mashup. So Game Boy, anyone ever have a Game Boy? Probably the same people that, okay, oh, more, okay. So yeah, Game Boy and, cool portable device, the first portable game system, maybe not the first, probably the most popular. Game Boy printer was a device that you could have with certain games. You could take screenshots and take pictures and print things out. And that interface, somebody had reverse engineered, a kind of hardware hacker out of France had reverse engineered the interface as some serial interface that you could connect to and actually send data to the printer and print stuff out. This laser rangefinder on the left is a project that I designed that is now discontinued, but it basically used a CMOS camera module and a laser diode to do triangulation as a simple way to do range finding. And the intent there was these were sold by a company called Parallax for hobbyists and people building robots. And it was such an easy way to explain how range finding works. It's all trigonometry, which I had to relearn as I was building this thing. So I said, all right, what if I combine the camera, the laser rangefinder, with the printer and print stuff out on the printer? So there's my little board hacked together because I had to get the interface, connected up to the Game Boy printer. Cheese. It's very exciting. It took a long time to send that data serially of the image. So now you can also have your own low-resolution pictures of useless things if you combine them together. But this is something, this goes to show, not every project you do has to be serious, right? With the show and with the badges, those were serious things, but this is the type of stuff I love, and this is what reminds you of, oh, engineering was fun, or it can be fun. It doesn't always have to have that stress, even though I know a lot of times, you come home from working, the last thing you want to do is work on more electronics. But it is something fun of okay, I learned some cool interfacing tricks that, maybe I can use for something else. Ooh, I like this one too. This is awesome. I hope you guys recognize this man. Okay. So there's the Virtual Boy, another Nintendo product. This one didn't do as well as the Game Boy. And Tom Selleck, right? Yes? Okay, geez. You guys, you're killing me. 3 people know Tom Selleck. Okay, this was, actually, I'm not even, what was he in? Was it Miami Vice? Oh man, this is bad. Oh, Magnum PI. Good, you are listening. Okay, so mustaches, awesome. I can never grow a mustache, so I made this thing instead of what if I had combined Virtual Boy system with Tom Selleck and created what I called Mustache Mayhem. And this was a project, really, the goal for me here was to learn about using a BeagleBone Black, so Linux-based platform, I'm not a great software person, so I was just kind of hacking together different libraries, trying to figure out how to administer Linux and deal with all that. So it was a good process for that. Got to reverse engineer the Virtual Boy controller and see how the controls worked, and replaced most of the circuitry inside the Virtual Boy with my own stuff that would have, well, I'll show you. I'm not even going to explain it. So I'm going to turn it on. It's going to boot up. Boot screen is a little faster than normal because I sped up the video, because you don't want to watch Linux boot. So now there's a volume control under there, so I'm adjusting the volume, and I'll be quiet for a second so you can see if you can guess the song that this is. Thunderstruck. Yes, it is Thunderstruck, AC/DC, but then listen carefully. So it's Mustache Struck. So I just took a chiptunes Thunderstruck and, made it say mustache. That mustache sound was actually from Napoleon Dynamite. So here, so it has a camera on it now. And when you put this thing in front of your face, it's going to add mustaches to your face. So you can pretend you have a mustache and you get points. When somebody's in the frame, you push the button. And then you can, set a high score based on how many faces and mustaches you can get. So I used OpenCV for that and a bunch of open source Linux libraries. And it turned out I submitted this to like an art show. And the concept that I came up with is like people love being in front of the camera, especially when you do something silly like that, right? Like put your face in front of the camera, you're getting a mustache drawn on it. But it really highlighted the fact of like, I could be using all of this data and selling it to Facebook and Google and whatever. So it kind of highlighted like the technology versus the commercialization of that, or the data harvesting and the dangers of surveillance and everything. Because everybody that I went up to with this thing put their face in front of it, which was really kind of scary and surprising. Did I ever do something with a real mustache? Oh, yeah, I did take a picture of somebody with a mustache, and it just drew a better mustache on them. Okay, so here are some slides of like maybe some useful things for the talk. And yeah, so I have 101 of them in binary, right? That's a good nerd joke, isn't it? Yeah, okay, geez, good. So these are not groundbreaking things, but as I started putting this presentation together, I'm like, what kind of tips would people use? And a lot of times we sort of forget about things that we can save a lot of trouble if we just kind of did this stuff. So checking footprints. A lot of the stuff that I do, I don't have, I don't use Altium Vault. I don't have a bunch of other engineers working with me. It's just me working on projects. So I'll draw my own footprints. Sometimes I will use third parties to look at their footprints, but I always want to verify those because actually a lot of them I've looked at have problems with them. There's some inconsistencies. So I always want to verify that. For big stuff, that's easy, right? If it's something that's a connector or a switch or something, that's fine. But if you're dealing with BGA stuff, this might not be possible. The only way you're going to check for your footprints is you X-ray it and see. But these are just something, I'll print out a one-to-one and place my components, see if I like that placement of how it looks aesthetically. The upper right, that was the DEF CON 27 badge. That's the backside of the last badge I did that nearly pushed me over the edge. And had some really small BJ parts on there. That badge was actually used near-field magnetic induction for communication. So basically, it's like two transformers and or two coils and an air core communicating between them. And it was sending data back and forth between badges, and there's a whole game associated with it. And with all the crazy complex stuff, I hand drew all the footprints for the BJ stuff, looking through the NXP data sheets and crazy footprints and the solder mask over the pads and whatever that's called. Like it was a mess. But it all ended up working. It was amazing. It's like we X-rayed it and the factory is like, yeah, everything lines up great, except your LED hole is too big. And I'm like, it's like all the really high-tech stuff was fine. But then it was like that one oversight where I followed the data sheet to build my footprint, but I didn't print out a one-to-one and didn't test it. And we had to build 6 prototypes. The 6 prototypes we built, it was $4,000 for the order. And I had screwed it up. And luckily, they could hand solder those for testing. But if that was like a bigger project, that could be a big problem. So that one, we ended up reducing the whole size, and then we had to push the pads much closer. And I don't remember what it was called, but they kind of cut the fab arced the inside of the pad so we could still have a good hole to account for worst case tolerances of the epoxy around the LED, but still have good solder connectivity because we're placing 6 of these on 28,000 badges and machine placing. So it ended up working fine, but that was a kind of an embarrassment and a reminder of always check your footprints, no matter how simple you think it might be. And then the one down here, this was also another one showing kind of initial parts placement. This was a DEF CON 18 badge, and just verifying some stuff and then going, kind of iterating through that process. This is another one that's sort of obvious, verifying your solder connections. I like to hand build stuff if I can. Again, if you're dealing with BGA stuff, you might not be able to, unless you have in-house X-ray to verify things. But this is something with hand building prototypes, it's important to check. And this was one I'd used my circuit board prototyping machine on prototype this. This was part of the personal airbag system, which was intended to detect if somebody's falling from a height of 30 feet or higher and then deploy this massive airbag around them. If you fall off a ladder or try to jump off a building or something. And we had a Freescale part on there, microcontroller, a bunch of relays to trigger the solenoids to engage the airbag system. And on the back side, there's this little accelerometer. And nowadays, this would be easy because so many accelerometers just have a free fall detection. It would just trigger some I/O pin or some interrupt, and it's like, oh, now we know we're falling. We'll just do whatever. But here we had to have a whole algorithm that's detecting if we're free falling. But it's this QFN part, and on this copper-clad board, solder connectivity is not that good, right? There's no solder mask. There's no plating on there or anything like that. And we had a little bit of a problem that I did inspect it, but it turns out I kind of missed something. So here's part of the show from Prototype This where we're doing a test of the circuitry to see if it can detect a free fall. Inside of this box is an airbag with a ton of popcorn. So the concept was as it would detect the fall, the airbag would explode and popcorn would go everywhere. But here's what happens when you don't check your solder connection.
When Zaz pulls the string, the airbag inside the box should inflate when it detects a fall greater than 10 feet.
3, 2, 1.
But the box smacks down hard.
So that was a little nerve-wracking because the next day we were doing our final test with a human. And I wouldn't want the human to end up like that box. So we go back and I'm like, this is so weird. And on the show, I'm like, oh, it wasn't turned on. But then we go and inspect the board, and it turns out that one of the connections on that QFN, because you're really not supposed to hand solder QFNs anyway, right? That solder connection, the fillet or whatever it's called, wasn't there. So there's no solder connection on one of the pads. And so the accelerometer wasn't working. And it was like, oh, man. And they made a whole thing about it. I got a whole bunch of grief on the show. And I was like, well, you guys design an accelerometer circuit then. But it was something that we're like, OK, that was a simple fix for the problem. And so here's the finale of this one. So I guess now you don't have to watch this particular episode if you don't want to. But it is still a good process. Here we had a stuntman. His name is Tim. He did a bunch of other stunts for us, but this one he was like legitimately scared because he's on this, what do they call it, like a cherry picker, 30 feet up in a giant warehouse gymnasium. And he has a bunch of cables set up onto him and a bunch of safety people. And he's like, he's pretty serious and pretty scared. But here's what happens.
It all comes down to this, the moment of truth.
And 3, 2, 1.
I think he was a little bit stunned by the force of the airbag. But at least it deployed, right? So that was a good thing.
And that is how you do an airbag.
Yeah, so check your solder connections. Here's one that probably a lot of people can relate to, right? Keep it simple, stupid. We know that acronym. Don't overthink the problem. As engineers, a lot of times we get so focused on something, it's like, why is this not working? What's going on? And it can be a simple problem that ends up taking you months and months to debug. So if you try to think about the simple things first, this example, this problem, this is an RFID, one of the RFID modules that I've designed. There's sort of a family of them that are sold through Parallax, again, for hobbyists, or maybe some industrial usage. Just an RFID reader. There's a read-write version as well. And I was converting a serial UART interface to a USB interface. How hard could that be, right? Just throw in like a FTDI USB to serial adapter, and now you have USB functionality. I think I did put in a a current limiting switch in there. But it should have been a simple modification to create this new version of the board. And I was getting the boards back, and I was getting all these errant reads. So the board was telling me that there was a tag in front of it when there wasn't. And I'm like, well, that's weird. All the other products have worked fine for 5 years. Like, what's happening? And I just went down this rabbit hole that took 5 years to figure out. And this is really what hit home about don't overthink the problem. Think a little simpler. The pictures on the right, the upper right, that oscilloscope screenshot is showing the demodulated data coming from the RFID reader chip before it goes into the microcontroller. And the microcontroller is going to process that, figure out what the data stream is. That's what I was measuring at first. And the bottom one is from a board that wasn't exhibiting any issue. So that was like the legitimate data. But I don't know about you, but besides those bits being a little bit different, it still looks like valid digital data, right? Like there's no weird stuff in there. And yeah, maybe it's a little noisy and stuff, but again, I'm not a signals integrity guy. I actually will try to avoid RF now forever. So I tried all sorts of things. I did a surgery of taking a good one and modifying it with the other one, trying different capacitors and stuff. It turns out in the wrong places. Tried looking at the software. I was like, maybe there's a bug in the software that's doing something. Like, why is it telling me that there's all these reads when they're not there? And it turns out that it was one of the filter caps was, I don't remember the values, but it was an order of magnitude off. So too low. So I was just demodulating a bunch of noise that the antenna was picking up and treating it as digital data. And then the software was getting confused because sometimes all that noise appeared to be like a valid packet or valid enough to show the data. So I just had to swap that capacitor value, which took me 5 years to figure out, not full time, but a few days at a time, and then I'd get frustrated and throw it on the ground and then come back later. But just a single capacitor value fixed the whole thing. And that was just a killer. Taking small steps. This is something where we don't always have the luxury to do this, right? If we're under time pressure to get stuff done, we might have to go from prototype to production right away. But I like to usually go through iterations of builds. The one on the top was one of my first production devices. This was a human portable infusion pump that was actually used on humans. It was pretty amazing. And it was a complex system. We had an 8051 on there. We had a Dragon Ball MC68328. So two systems, one controlling like the pump human connection and one controlling the user interface. So if there was a problem with one, it wouldn't mess up the entire system. It passed FDA 510. And this is really where I cut my teeth on the whole production process, which was awesome. But we started off with massive boards, right? Everything easy to access, test points, everything to make it really easy to debug. We had sockets in there for things. And then we went a little smaller, and then we went final design to fit in the housing, right? So that's like the best world if we have time for that. That process took 2 years. It was great. That company ended up, it was a venture capital-backed company, and I didn't know this because I was just an engineer working on it. But it turns out that by the time they got to this stage of testing it on humans, the VCs were like, nope, we want to make our money back, and just messed up the whole company, which was sort of a bummer. But that's one of my proudest designs, to see it through, starting from something all bare metal. We wrote everything, which is really cool. The bottom one is something I designed with my kids who are in the swimming pool right now. And I tried to, I was like, you want to come see my talk at AltiumLive? And my younger son was like, Daddy, I'm just not interested in electronics anymore. And I'm like, oh, I failed as a father. Or some may say that I've succeeded as a father because now he's not going to be an engineer. Because it depends on how you look at it. But this is a project I did with my kids of turning something that they had seen on a show called Wildcrafts, which was something called a creature pod, which was like a wrist walkie-talkie thing that, in the cartoon, the people would talk to each other on this wristband. So they wanted to make one for real. And so we prototyped the whole thing. This was another Arduino-based system. We had a little radio module and built our breadboards, built 2 of them because they're walkie-talkies, and did testing together. Like we walked through the neighborhood to check range and everything. And then again, did our one-to-one printout to make sure everything looked like the original one, and then came out with the final ones at the end, which were kind of cool. Here's a few others. So that top one is from DEF CON 15, where we had a row, 95 LEDs in a matrix to blink different messages and things that you could program on there. Never give hackers the right to print messages on things. A lot of interesting stuff on those. But this was something where I built up my original prototype to test it, and then realized that when I was doing the capacitive sense buttons, I didn't totally read the data sheet, which is a bad idea. You always want to read the data sheet in full, and even if it's 300 pages. It turns out that I misread the data sheet actually for this, and the power supply, I normally run these badges on a single CR2032 coin cell, so 3 volts. But these required 5 volts to be stable, and it wouldn't work at 3 volts. And I'm like, oh no, can I use a boost converter? No, I don't know, it's going to generate too much noise. It's not going to work with the capacitive touch. So I ended up having to add another battery on there, and that was something, if I hadn't had the time to do that, I would have been screwed, right? And that was just an oversight on my part. But again, having that luxury. This bottom left, that was the prototype for the DEF CON China badge, which was a flexible circuit. Who's designed Flex before? A bunch of people, okay. When you design Flex, I'm curious about this. When you design a flexible circuit, do you design it on a rigid board first so you can verify functionality, or do you go straight to Flex? Straight to Flex. Yeah, so I did the same thing. I went straight to Flex on a board I had never tested, and it almost all worked, except one of my transistor pinout was wrong, because it's a SOT23, and sometimes the vendors switch the pins around, and it turns out that that was swapped. So I had to cut some traces, and cutting traces on a Flex board is ridiculous, right? Because your substrate is like a polyamide, whatever, I don't even know what the thickness is, like ridiculously thin. So it turns out when I was cutting the trace, trying to be really careful about it, I was cutting into the ground plane on the other side. So then the copper was shorting, my signal line was shorting to the copper plane, and I was like, oh. So if I had the chance, what I would have done is built a rigid board first so I could verify layout, verify at least connectivity, and then go to the Flex. But luckily, it was just that simple fix, and I eventually was able to lift the copper plane from that trace and reroute it, and then put some super glue on it to prevent anything else. And that was the one board I used for all the development, and then we went from that board to production of 3,000 for that one. I couldn't think of a better name for this one. But I guess design for test. And this totally actually, designing systems for test goes against everything that I teach when I tell people about hardware hacking, because when you're hacking embedded systems, you're looking for everything that legitimate design engineers are putting on the board. We're looking for test points, we're looking for connectors, debug interfaces, things hidden, covered over in solder mask, everything that we need during the manufacturing process as legitimate engineers, hackers can use. So design for test is sort of like, maybe you want to design your system for test, but you want to, don't put too much in, just the bare minimum. So this was an example on the show. This was Mike North, our material scientist on the show, was testing the strength of these carbon fiber composite legs that we were using for that 6x6 all-terrain vehicle. And I don't know why he came up with this, probably because he's trying to show engineering as being cool. So he's like, let's build this crazy contraption where we're going to test the strength of the leg. So I guess maybe the title, it shouldn't be design for test, it should just be like, make sure you design your tests properly or something. But here's what happened. I don't know if this made it on the show either.
Action, please.
So poor Mike will never live that down. That's his crowning achievement on prototype this. Falling off the, I think he called it the forklift rodeo or something like that. So I don't know, you can probably think up a better name for that, but just be aware of what you're testing, how you're testing it, why you're testing it. Okay, I've been waiting for this part. If any of you read my abstract, I said in there that I would profess my love for ferric chloride. How many of you have etched your own circuit boards with ferric chloride? Nice. Awesome, yeah, okay, cool. So this is another thing that really got me into engineering, is where you could build your own circuit board, and you had your copper-clad board. You had to route your board with rub-off letters or a permanent marker. Later on, you could use an iron with a toner transfer, and stick your board in the ferric chloride. Maybe you had a heater, you could heat it up, you could agitate it, and 10 minutes later, 20 minutes later, you take your board out, you clean it all off, and now your board's ready to go, and you can then go do whatever you're doing with it. I didn't know at the time, ferric chloride you're not supposed to dump down the drain, so I did that at my parents' house, so if they ever wonder why the sewer pipe is leaking, that's probably why. But it was just such a fascinating thing, right, to be able to create your own board with this instant gratification, and that's really what got to me. And nowadays, kids these days, have it even easier because there's so many circuit board fabricators you can use. The design tools are much better, right? So shameless plug for Altium Designer. The resources are there that you can make your own stuff very quickly. But doing this ferric chloride and sitting in my parents' basement was just such an awesome thing. So in my abstract, I said, I'm going to profess my love for ferric chloride. So I wrote a poem. And I'm going to read the poem to you as sort of my closing remark. And so it goes, FeCl3, which is ferric chloride. That's what Wikipedia told me. Etch away the copper clad. I am beholden. So there, professing my love for ferric chloride, it changed my life. And engineering changed my life. And yeah, so that's sort of my story in a nutshell. I appreciate you coming and enjoy the rest of the show. And I don't know, maybe we have time for questions. So thank you.
Nerd, right?
Turbo nerd.
Turbo nerd. Yeah. I actually watched every episode of Prototype This, Joe.
Thank you.
I absolutely did, and I actually really enjoyed that show. I like Joe very much. Just personally, I've known him a very long time, and clearly he's entertaining. But I think he represents, his story is not dissimilar at all, I think, to many, many people. And we spoke about it. It's no coincidence that his presentation lined up with what we're sort of pitching here this week. And my story is very similar, only I had a TRS-80.
Nice.
Anybody here have TRS-80?
Was it the model 1, model 2?
Honestly, I don't remember.
Yeah.
And I remember it had a tape deck drive.
Nice.
And we had a big magnet if you wanted to erase the cassette tape for the storage. And I remember, so I saw your dog. I remember we got a BASIC. My father was an engineer. We had a book for BASIC. You could learn BASIC.
Yeah.
I remember sitting there all day and just sort of copying lines out of there, go to, bang, bang, bang. And it like drew a circle and made a sound. And then, I really saw my life sort of going like yours, but then I discovered girls, Joe.
Wow. That's where you went wrong.
And now I'm in marketing and stand before all you guys. But in reality, I think that Joe's story is very similar. Obviously, he takes it to another level when we talk about this. He's living a lifestyle here. And I just find it very, very fascinating and obviously very entertaining. So thank you very much, Joe.
Thanks. I appreciate the opportunity again.
Also, one more thing. Wait.
Oh.
Joe got the last of the free stuff. So if anybody's going to call me and ask for free stuff,
That's
don't
right.
do
Yeah.
that.
All he'll say is no. It's still worth asking.
Thanks, Joe.
All right,
Appreciate
thanks
it
again.
very much. In actuality, if you do have a chance, I believe all those episodes are actually on the Discovery Channel website, Joe? They might have taken them down, he says. Amazon has them, okay. So it's really an entertaining show, and I don't think he actually makes any money from it, but nonetheless, it's a good show. So that concludes the day. I hope everybody had a great time and enjoyed and learned a lot and connected with a bunch of people and got inspired by all the cool things that they saw. So what we're going to do now is sort of release everybody, but we are serving cocktails now at the pool. So if you guys want to go over, have a drink, talk to your colleagues, meet some new people, by all means go over, have a drink. We'll start dinner at 5:30. And if you're not planning on going to the dinner, once again, shame on you. You will absolutely enjoy the dinner. So also, tonight we're having a drawing by CR Circuits, and they're giving away a Mavic Pro, which is, if you ever played with a Mavic Pro drone, they're really, really cool. If you haven't got your raffle tickets, by all means go speak to them, get your raffle tickets, and you got a chance to win. And I think that's it. Thank you very much.